Hey guys, it's Mr. Zimmerman, and if you're at the level where you've completed all the formatives and you are preparing to take the summative, you're in the right spot as we're going to do a review of a myriad of problems you might see on the summative. So we're going to go ahead and just start with number one, and we're going to work our way through A, B, and C. So number one, let's just kind of give a little intro. Basically, it's trying to check if you understand what an exponential function is, if you can graph one, if you can create a visual model of it, and then you need to do the same for the inverse of it, because that's been the theme overall. So let's go ahead and dive in, shall we? So we're going to look at 3 to the power of x. It's an exponential, and the reason I know is because the x is in the exponent. So I know this is exponential. And we know something about the inverse, but we're not going to jump into it. We know that the inverse of it is going to be a log, but we don't necessarily need that information right now. So we're going to go ahead and create our table of values by substituting. I'm going to plug in 3 to the first is just 3, and then 3 squared is 9. Now, at some point in your adventure, you should know that any number raised to the 0 power is going to have an output of 1. And I know that this is going to be the inverse. It's going to be 1/3 and 1/9. Now, I'm going to do the same thing, but for the inverse. And all I need to do is switch my x's and my y's. So my x's are going to be, I'm going to cross that out. I'm going to put 1/9. I'm going to cross that out. I'm going to put 1/3. I'm going to cross that out. I'm going to put 1. Likewise for 3 and 9. I want this process because essentially what I'm trying to get you to do and notice is instead of always using -2, -1, 0, 1, and 2, I do have to alter my thinking when thinking about the inverse of something. Now I'm going to go ahead and fill out the table because the numbers are just switched. I got -2, -1, 0, 1, and 2. Now let's go ahead and graph this guy. When you're looking at the exponential, you know that it's going to generally, this is going to be a growth. The reason I know is that 3 is greater than 1. So it's going to go ahead and be growing. So it's going to look something like that. So I'm going to plot my points, and I'm going to start out with the nice ones. I'm going to get 0, 1, 1, 3, and then 2, 9. Notice how much of a large increase it is. It is increasing exponentially. Now, I know that's going on and on. I'm going to tackle the other side. -1, and then the fraction's 1/3. Well, I know 1/3 is smaller than 1. I know 1 is right here on this line. So I know it's going to be below it. So -1, 1/3 is going to be here. And I know that 1/9 is going to be much smaller. So you can see here that it's going to be approaching 0. Never touch it. So I take a very careful detail when I'm drawing this line, and I'm making it over the x-axis. To draw more attention to the fact that it never touches it, I'm going to use another color to represent the horizontal asymptote at y equals 0. Now my inverse, since this has an asymptote at y equals 0, and it's a horizontal asymptote, I know this guy is going to have a vertical asymptote where x is 0. Part of the process when we switch the inputs and the outputs, also known as switching the x and the y's, is we're going to do it in all instances. So this graph of the inverse is going to have a vertical asymptote where x equals 0. So now we got our exponential growth function. It's important to note that, hey, does this grow? And absolutely it does. Now let's graph the inverse. So I'm going to start out again with my natural points because that's how I'm going to handle this. And I'm going to go ahead and put 0, 1, 0. So my x value is 1, my y value is 0, and I'm starting here. Now I'm going to go ahead and go 3, 1, And then again, using natural numbers, I start my graph, start building a picture where it's easiest, and I'm going to graph 9, 2. Now to finish off, I'm going to graph the spot between 0 and 1, which is this extremely small area. So in essence, we're going to zoom our minds in, and we're only going to look at this part. I'm going to go ahead and graph 1/3 and -1. Now 1/3 is going to be between 1/2. So it's going to be a little bit before half, and it's going to be -1. So I'm putting that there. And then for 1/9, I'm going to do -2. So all that matters is that it's a little to the left of this dot. And then I can kind of get the idea that this is going to go very close to my horizontal asymptote and never touch it. Now, how is it going to end up? Well, when I think about my inverse, it's increasing. So I'm going to go ahead and finish my graph. Voila. So notice how the inverse, it does look like the opposite. A lot of things have switched. Some things I want to highlight right now while we're just talking about it is notice how this has a y-intercept at 0/1, which is always true, making that the inverse always having an x-intercept. I want to draw attention that the growth function does not have a x-intercept. There cannot possibly be one because of the asymptote. Likewise, the opposite is true. There is no y-intercept, but there is an x-intercept for the inverse. So this really just displays that you understand the input going in and the output, and it's just testing your ability. Can you construct an understanding in a visual model of this equation? Let's go ahead and talk about it with the key features. These have been questions that we've been asked all year. And you can see in my table, I've already filled in the end behavior. This is because this part of the process, there's 2 specific questions that we're asking. And it's best to kind of just write this down so that your brain can generate it later. You notice how I write x goes to -infinity. And underneath, I leave a space where I write f of x is equal to something. And likewise, I'm going to leave a space here and here where I'm going to write a conclusion that I'm going to draw. But you notice it's the same question every time. As x goes to -infinity, and underneath I write f of x equals, and then x goes to +infinity, or I just disinclude the positive part, and then I write the same thing, f of x equals. That means because we're examining it from a different angle, it might have a different answer. And likewise, I do it for the inverse. So now I did that before I started drawing any conclusions. I'm going to go ahead and identify the domain and the range of the function. For the f of x, make sure you understand that I am talking about this guy, this graph. I even need to do it to remind myself. Here, the inverse is talking about this guy. So looking at the graph on the left, I know that my domain is going to be starting from the left side of it. And to show this, from the left side, going from -infinity off screen. So it's going through all the negatives possible. And I'm drawing my domain, and I'm tracing it as it travels to the right. And I notice that although it starts slowing down, it's still gradually increasing. So if I stretch this for a long enough time, it would go forever. So my conclusion is that the domain is -infinity to infinity. My range, I'm going to do the same test, but this time I'm going to be examining the y value change. So I'm going to start out and notice that it's always very, very close to 0. Like it never touches it. It goes from 0 and all the way up. It does not cross this negative sphere. It is only including the positive values. When I examine it from the bottom to top, it is not including negative numbers. So my range is it is never allowed to touch 0. and it goes to all the positive numbers. There are no negative numbers allowed. I'm going to do this for the graph on the right now. I'm going to go ahead and identify, hey, what is the domain? I'm going to use the same color green. So right away I notice that my adventure starts on this side of the graph. There is nothing on the other side of the graph where the negative part is. So my journey is going to start at 0, but my graph actually does not touch 0 because I'm aware of the asymptote. So my domain is going to start at 0, and it's going to go all the way to infinity through all the positive numbers. When I look at it at the range, which is a bottom to top scan, this time I notice that it is negative numbers. It goes through all the negative numbers, and it is slowly increasing. Now you might say, like, wait, it doesn't go through all the positive y values? But trust me, if infinity is a long time, and as long as it's increasing just a little bit, it will get through all of the numbers. So wait, my range is from bottom to top. It includes the negative parts, it includes 0, and it includes the positive part of the graph. That means all numbers work through negative numbers up to the biggest positive number. Now, something I want you to draw your attention to right now is notice that the domain here, my x got put in the inverse's y spot. And likewise, that my range, the characteristics are the same as the domain of the inverse. And this makes sense because we switched my inputs and my outputs. We switched the x's and the y's. And the domain is just an examination of the x values, and the range is just an examination of the y values. Now, let's go ahead and record some of this stuff. We've already been aware of it at multiple times. Now we're just trying to check for form. The asymptotes for the inverse, it is a horizontal line. So it is going to be a horizontal asymptote, and y is going to be equal to 0. On the right, it is going to be a vertical asymptote, the opposite, where x equals 0. Notice again, my x and my y were swapped. My x-intercept on the left, there is none, meaning that for my inverse, there's not going to be 1. Here, my 0, 1. And notice, I just want to draw attention to the form, the xy. If I look at the inverse, it is a 1, 0. It is an x-intercept. And notice that the x and the y, it got swapped from the previous. The y became the x. The x became the y. Now the final part is the interval of increase and decreasing, and from a growth equation, it is increasing forever. It is increasing from negative infinity to infinity, and notice how this mirrors my domain. My intervals of increase and decrease for my inverse, it is going to be increasing the entire time as well. The reason why it's increasing is because when I examine it going left to right, it is clearly increasing. Because if you looked at it right to left, it would appear to be decreasing. But remember, just the same way you read, math is a language, we do the same thing. All right, so this was a closer examination of just the domain and the range and all of the key characteristics of an exponential function and the inverse. We did all of this without knowing a single thing about logs. Join us next time as we continue to explore and review topics. That's it for now. This is just an addendum to the previous video. I forgot to talk about the end behavior. We're going to go ahead and address that real quick. As the original function, the growth function, is going to negative infinity. I'm looking at the graph over on this part right here. And where is it going? It's going closer and closer and closer to the horizontal asymptote. So that guy is going to be 0. When I look at it as it's going to the right forever and ever and ever, I notice how it's going up. It's going to be a very large positive value. When I look at the inverse, when I look at it as it's going to the left forever and ever and ever, it's approaching this asymptote. So I'm going to say 0. And then as it's going to the right, I notice how it's getting very, very, very much bigger. It's going to be infinity. Notice how the end behaviors are the same.